Hello, I'm Daniel from LieberLieber. Today I'm going to show you our Embedded Engineer in a special version for Windows 10, IoT and Raspberry Pi. Embedded Engineer comes from real embedded system and it all started with C and C++. It allows you to generate code from models and debug it on a model level. Today I'm going to show you with Windows IoT and Python. For our demo we use a Raspberry Pi with some relays and a traffic light mockup attached. It's all in housing. First up, I show you Visual Studio 2015 with the Python solution that is running on the device. Now I bring up LieberLieber UML debugger and open up the UML model from Enterprise Architect that was used to generate the source code that we just seen in Visual Studio. I bring up a state machine, the main state machine, and you will see in a second this is what controls the behavior of our system. So basically we have kind of an API to control the LEDs or lamps, and we use state machines to make an application. Now my debugger is connected to Visual Studio, so Visual Studio is doing the real debugging and this debugger is just a visualization. You could see I set the breakpoint and the breakpoint also exists in Visual Studio. If I click on a state, you can see the code that corresponds to the state or the transition, and I can also continue stepping over in the UML debugging environment. So for the first time you really have a good chance to understand the code you generated from UML in a very good way, because you still have the UML visualization of things while you debug the system. So here is my lamps, and as you can see we are in a breakpoint, and it's before this transition, and when we go next and go back you will see the transition happened and my lamps actually changed what they are doing. We are now in the state car has green, and of course our pedestrian lights should be red in this state. I remove the breakpoint and I continue the execution, and you can see the system running. And interestingly, from pedestrian green to car there is no blinking, but we are Austrians, so we got to fix that. We fix it. Basically we have the UML model in Enterprise Architect. We use LieberLieber Embedded Engineer to generate the Python code. The Python code is then compiled with Visual Studio and deployed. So here is the state machine. I already prepared a state that enables this green blinking. I move it to the diagram, and now I have to change. I move this to self transition, which does the blinking, so you can see it better. And then I have to move the transition from pedestrian green to all red to this green blink state. What I have to do next, now my model is changed in Sparx Systems Enterprise Architect. I call LieberLieber Embedded Engineer, the Python version, to generate Python code. The code is directly generated into my project directory. Visual Studio tells me there's new files. I click yes, I want to load the new files. Next up I have to rebuild the solution and again deploy it via LAN to my Raspberry Pi Windows 10 IoT device. Now we started debugging, and I bring up the camera and the solution currently loads and all lights are initialized, and now we're in the red state. The pedestrian goes green, and surprisingly the pedestrian light is now blinking green. I hope this helps you to understand what we are doing. One of the key differences between our solutions and solutions from the past is that we also have the missing link, the visualized UML debugger that helps you understand what you modeled in code. Here is a short picture of the making of, so you can see it was not a fake. Thank you for your attention, and if you're interested in LieberLieber Embedded Engineer, Sparx Systems Enterprise Architect, or other topics, feel free to contact us at any time.